Hello students, welcome to ACE Engineering Academy and ACE Online. Today we are going to discuss the memory based questions and the weightage analysis of computer science engineering paper, and the session is forenoon session paper. Coming to the weightage analysis, here this time the paper is not so easy, and I cannot say it is not too tough, it is in a moderate level, and the questions are, as we have collected memory based questions, what we have observed is questions are more analytical based. So means the students who have more conceptual clarity can able to crack the GATE exam this year very easily. But those who doesn't have a conceptual clarity, they might confuse with some data given, and they might confuse with options that they have to select it. And that thing the clearly maintained by IISc Bangalore. As you have seen the previous IISc Bangalore papers also, those are more analytical based. So means conceptual based, those who have more conceptual clarity, they can able to crack the GATE exam. So the same thing happened even this year also. And coming to weightage, discrete mathematics, the number of questions that what we have observed is the 6 questions, and from theory of computation 4 questions, and compiler design 5 questions. I have seen that these 5 questions are comprising 8 marks. This is all time greater marks, means all time the highest marks that was given in the compiler design subject. Previously the compiler design they have used to give 4 to 6 marks, but this time they have given 8 marks from the compilers. And even database management system, there are 6 questions, and totally it is of 8 marks. And similarly a somewhat lesser weightage when compared with GATE 2023 in computer networks. In GATE 2023 in computer networks, almost 12 marks asked, but this year only 4 questions, something around 6 to 7 marks was asked in computer network subjects. And from data structures there are 5 questions, and programming languages 5 questions. Have seen some programming language questions where the questions are very good, and they are going to put students in a trap to select some of the wrong options. Those who have very clear concept, then only they can able to answer those PL questions. And operating system 6 questions, digital logic 5 questions. Last time digital logic they have asked only 2 questions, this time they have given good number of questions, 5 questions, almost it is 6 to 7 marks in from digital logic. Algorithms 5 questions, computer organization 4 questions. When compared with 2023, in 2023 from computer organizations more questions were asked, but this time somewhat lesser questions. As usual, general aptitude is 10 marks and comprised of 15 marks, and there are totally 65 questions. And when it comes to the distribution of these questions according to multiple choice, numerical answer types, and multiple selection questions, we have observed that there are totally 23 multiple choice questions, and numerical answer type questions are 16, and multiple selection questions are 16. And this pattern is very similar to the pattern that is given in 2023 also. In 2023 also almost 16 multiple selection questions and 15 numerical answer type questions, and multiple choice questions in 2023 is around 24 questions, means almost similar pattern is maintained even in this 2024 paper also. And most importantly, we can proudly say that 95% of the paper is from our ACE online, offline, and our test series and pre-recorded lectures. Means it is the meaning that the similar pattern of the questions that what we have discussed, similar pattern of questions you can definitely see in GATE 2024 papers, right? So we can proudly say that almost 95% of the questions patterns are similar to our questions. Here I am going to continue with database management system subject. Here in database management system there are total of 6 questions, And in that 6 questions, there are 4 1-mark questions, 2 2-mark questions. Previously, they used to give hardly 1 or 2 1-mark questions, but this time they have given 4 1-mark questions and 2 2-mark questions. And this total comprises of 8 marks. And a question, again as usual, 6 questions are from 6 topics, because when you see the previous year paper patterns of 23, 22, 21, whatever it may be, the previous 10 years pattern, every year you are getting something around 5 to 6 questions, and all these 5 to 6 questions are from 5 to 6 different subtopics. Here one question is on ER models, and another question is on functional dependencies, and normal form 1 question, relational algebra 1 question, SQL 1 2-mark question, and B plus tree indexing 1 1-mark question. So there are totally 6 questions from 6 different topics. We'll go into detail about those questions. Here out of 6 questions, we have got the proper data of 5 questions. That 5 questions I am going to discuss in very detailed way. Please listen to it. Yeah, look at this question. The question asked on relational algebra. It is given 2 relations, relation R and relation S, with A and B attributes of R, A and C attributes of S. The question that was asked is, find the number of tuples in the output of the following relational algebra expression. This expression is given, and this is a numerical answer type question. Fill in the blanks. It is clearly given R and S are joined, and these two are joined with respect to the condition RA equal to SA. So means the joint condition is RA equal to SA. So A equal to A is mapped with this combination, and 20 does not have a match, and 30 had a match with this tuple, and this 30 also had a match with this tuple. These are the 3 matches, and 50 does not have a match. And this is an output of this join operation is the 3 tuples. From those 3 tuples, it requires to select those tuples satisfying the condition B less than C. Here the B value and C value for those matching tuples. Here this is a match satisfying the condition RA equal to SA, and the condition B less than C, 20 less than 30, 20 less than 30, it is true, and here 40 less than 45, this is true, and 50 less than 45, it is false. So means out of these 3 correct mappings, 2 correct mappings are satisfying the condition B less than C, so that the result is containing A, B, C tuples, because the joint condition is RA equal to SA. So A is appeared only for one time, and AB joined with AC will give you ABC. The result 10, 20, 30, this is one combination, and one more is 30, 40 and 45, this is another combination. So the question asked is, how many tuples in the output of this relational algebra expression? So there are totally 2 tuples in this relational algebra expression. Okay, this is one question. And coming to the second question, it is a 1-mark question asked on B plus tree indexing. The question is, the minimum fill factor of 50% is not necessary for dash. As we know that both B and B plus tree data structure will follow minimum fill factor of 50%. What does that mean? If the order is n, a node can have a maximum of n pointers and n minus 1 keys, right? N minus 1 keys. And minimum fill factor is 50%, means n by 2 upper bound of pointers and n by 2 upper bound minus 1 keys. This is a minimum fill factor. And this minimum fill factor is an exception for the root node. And every other node should satisfy this minimum fill factor. And you may ask me a question, sir, why exception for the root node? Suppose if order is 50, if order of the B tree is 50, if order of the B tree is 50, then in such cases what is the minimum order? Minimum order is 25 pointers and 24 keys. When you are constructing the B tree or B plus tree, we have to start with one key value, not with 24 keys. If we start with one key and that one key and the node that contains that one key we call root node, if there is only one key, it can have its left pointer, it can have its right pointer, but it is not going to maintain minimum keys of 24. That is the reason the minimum fill factor for the root node is exception of 50% and remaining all the nodes means both internal nodes and leaf nodes should satisfy the minimum fill factor. Here the options are given: root node, it is not necessary for the root node, and internal node it should be satisfied, leaf node it should satisfy, and it is also given left subtree. It is given left subtree nodes, this is also incorrect, and this is a 1 mark question. Yeah. Coming to one more question, and this is a question on functional dependencies. This is a question on the closure properties of functional dependencies and properties of functional dependencies. Here they have given 4 options and saying that which of the following FD rules, functional dependency rules, are correct. Here it is given x to y and y to z. These x to y and y to z are implying x to z. This is according to the transitivity rule. According to transitivity rule, it is possible. Here, if you remember these rules, okay. If you don't remember also, we know that if these 2 dependencies are given and asked to find this dependency is possible or not. How do you verify this dependency is possible or not? Find the closure of left hand side to see the right hand side using the dependencies that are given. It is a simple way of answering the question. So if we take the closure of x using the first 2 dependencies, we will get x, y and z. So that x closure is containing z, then x to z is correct dependency, means this rule is correct. And the question is MSQ, because it is MSQ we have to choose all the correct answers. Look for the option B, xy to z and w to y implies it is given xw to z. So how do you check xw to z is possible or not? Take the closure of xw and xw closure is xw, with w we have y in the second dependency, and with xy we are getting z in the last one. So that what it is deriving xw to z. So this is also correct, or else you can solve according to the properties. Look, here w to y is there. If w to y is there, we can add x in both the sides so that it goes xw to xy. This is according to the augmentation property. And you have a dependency xy to z given. Now xw to xy, xy to z, according to the transitivity rule, we can say xw to z possible. If you can able to answer in this way, it's happy. Otherwise you can check with a closure. So B is also correct, and C, xy to zw will determine xy to z. See, xy to zw according to the decomposition property we can write as xy to z and xy to w. So xy to z is correct one. And xy to zw implies x to zw. As you know that decomposition we can apply only in the right hand side but not in the left hand side. So that this is incorrect, or else you can try closure of x plus using the given dependency x plus is x but not zw. So this is wrong. So answer for this question is A, B and C. Fine. Now look at the third question. The third question is, fourth question it is, on transactions and concurrency control. As usual, I have told to my students many number of times, from transactions and concurrency control, the only concept that is very, very important is conflict serializability concept. And from conflict serializability, in the past 3 to 4 years, if you see, on almost every year, you can see one question on conflict serializability. Here, the question given is, consider the following schedule of 3 transactions R1Z, W1Z, R2Z, R3Y, W3Y, R2Y, W2X and W2Y. Okay, some schedule is given. And the question is, which of the following ordering is conflict equivalent to the given schedule? The orderings are mentioned and it is asked to find the schedule is conflict equivalent to which of these orderings. Again, this question is multiple selection question. How to solve this question? You have to construct a precedence graph. Construct a precedence graph for the given schedule. Here, how many transactions are there? There are 3 transactions. So, draw 3 vertices, one for each transaction, 1, 2, 3, and draw an edges for each conflict operations. What are the conflict operations? Read write, write read, write write of the same data item by different transactions. Look at R1Z, is it conflict with any of other transaction operations? So, it is W1Z, operations of same transaction does not conflict, and it is X, Y, Y, X, Y, so means this does not conflict with any other operations. W1Z, by looking this schedule, doesn't have any conflict, and R2X, R2X, W2X, but both are belonging to the same transaction. Operations of same transaction never causes any conflicts. R3Y conflict with W3Y, R2Y and W2Y. See, look at R3Y and W2Y. It is a read-write conflict. So, it is a conflict from 3 to 2, draw an edge from 3 to 2. And W3Y again conflict with W2Y and R2Y. This is a conflict is from 3 to 2. So, already edge is there, 3 to 2 drawn, and R2Y and W2Y operations of same transaction will not cause any conflicts, and W2X does not have any conflicts. So, here in this precedence graph we can see only one edge, and the question is to find the ordering, serializability orderings, like which orderings are conflict equivalent to the given schedules. How to find the orderings? Orderings we have to find by performing topological sort of the directed graph. How to perform a topological sort? Start with a vertices within degree 1, sorry, in degree 0. In degree 0 is there for vertices 1 and vertices 3. Suppose I consider the first vertices is 1, next vertices within degree 0 is 3, that is only one possibility, and the last one is 2. Suppose if I consider the first vertex is 3, now we have to remove the vertices 3 along with its outgoing edges. If you remove 3 along with outgoing edges, now these 2, 1 and 2 becomes isolated nodes. So, if it is isolated nodes, ordering between 1 and 2 is becomes 1, 2 or 2, 1, means 2 possibilities are there, that is 3, 1, 2 and one more is 3, 2, 1. These are the 3 orderings that are conflict equivalent to the given schedules. Given schedule. So, question is which of the following ordering is conflict equivalent to the given schedule? 1, 3, 2, look at this is a correct ordering, it is a correct, and 1, 2, 3 is not the correct ordering. Why 1, 2, 3 is not correct ordering? Because transaction 2 should happen after 3, but what it is given 2 then 3 given, that is a incorrect ordering, and 3, 1, 2, 3, 2, 1 both are given in the options. And it is a MSQ question. The answer for this question is A, C, D. 3 options are the correct options. And one question is asked on ER models, ER diagrams, and we don't have a diagram, but I can show you for these statements what could be the diagram. The question is which of the following is the correct ER diagram for representing the following statements. They have given 4 statements, and 4 options are representing the ER diagrams, and which ER diagram is the correct representation to be chosen. Look at the first one, students register for courses. So, register is a relationship, student and courses are the entity sets. So, how could be the diagram? Student is an entity set and courses is an entity set, and between them we have a relationship register, student register for a course. That is the first statement. Second statement says courses allocates classroom, means that for every course they are allocating some classroom. In that classroom that course should happen. So there is a one relationship between a course and allocates, course and classroom. We call relationship is allocates, and the entity set is a classroom. This is the one. And look at the third statement, instructor guides the students. Student already we have drawn. We have to take one more entity set, that is instructor. And what instructor should do? Instructor is going to guide the students. Instructor guide the students. And instructor teaches the course. That is the fourth statement. So instructor already there, course is already there. Between them we can have a relationship, that is teaches. It is mapping between these two. And this is a diagram that is matching with one of the options, and this is the proper diagram that we can say it is the correct answer for the question. So totally 6 questions were asked from the subject of DBMS of consisting of 8 marks. So these are the questions that we have collected from our students from different sources. Hope you have understood these questions very clearly, and hope you have done the correct answers for the DBMS. That's about for the DBMS subject. Next, my friend going to continue with aptitude questions and followed by all other subject questions and their detailed solutions. So don't go anywhere, stay tuned. Wishing you all the best. Good luck. Thank you.
Hello my dear students. From the aptitude we are approximately getting 7 to 8 questions. Out of the 7 to 8 questions we received some data from the students and the different sources. We are getting only 3. Okay, and remaining 3 data is very lengthy, not getting clearly, that's why. Okay, observe the first question my dear friends. Log of p square plus q square is equal to log p plus log q plus 2 log 3. Find the value of p power 4 plus q power 4 upon p square plus q square. Very easy question in our classroom student. Okay, who people are classroom, ACE online, everybody knows logarithm is very important, number of times given, same data is given in a CSE. And remaining branches also last Saturday and Sunday also. So here observe my dear friends, from this log p square plus q square, directly I simplified in a single step. Log a plus log b plus log like that. Log pq plus log 3 square. Again, so log pq9. pq9. So left hand side log p square plus q square. So both sides shall logarithm same, then answer base obviously same, p square plus q square, p q 9. I want p power 4 plus q power 4, that should both sides squaring. So p power 4 plus q power 4, 2 p square, q square, p square, q square, 9 square, 81. So p square, q square left hand side. So p power 4 plus q power 4 upon p square, q square. So left hand side p square, q square cancel, then 2 is equal to 81. So 2 right hand side, then final answer is 79 is the answer. One of the easy question, within the time you are able to solve this question, my dear friends. Okay. And next one more question, let's see. Ratio and proportion, this concept, number of times I mentioned, okay, coins concept. A person has 1 rupee, 5 rupee, 10 rupee denomination in the ratio of 5:3:13. 1 rupee 5 and 5 rupees 3, 10 rupees 13. Find percentage of the 5 rupees denomination amount in the entire amount. So this is the question. So here, denomination ratio 5:3:13. Convert into the amount ratio. 1 rupee coins, 5 coins. 1 rupee coins, 5 coins means what is the 1 rupees amount? 5 rupee. 5 rupee notes, 5 rupee. Each one 5 rupee, 3. 13 into each one, 10. So this is amount ratio. 5 rupee, 15, 130. This is amount ratio. Okay, amount ratio. Ratio means you can take x. So 5, 15, 20, 150. So 150, total amount I don't know, 150x. I want 5 rupees amount. I want 5 rupees amount means what is the ratio? 15 parts. Out of 150 into 100. That is equal to 10% amount. 5 rupees amount to 10% in the entire amount. So this one also within the time you are able to solve, my dear friends. And next, mensuration. From the mensuration, this time cover 2 questions. Okay, this one and next one also. This one and another question, information clearly not there. Next one of the question, data interpretation. That question also clear information not there. Okay. A rectangular sheet whose measurements 8/20 and then longer side only folded perpendicularly 3 times. Find the perimeter of the final figure. Find the perimeter of the final figure. So only perpendicularly folded, perpendicularly. Suppose this is 20. If you fold horizontally, means it is a parallel. But I want perpendicular, okay, perpendicular. That's the reason. First operation. After the first operation, the 20 become now 10. 20 become now 10. This is 10, this is 8. Okay, perpendicularly folded. Here in this first, after completion of the first operation, again 10 is the highest. Second operation, the 10 become now 5. This one 8 common. After the second operation. Now longer side, what is the longer side now? 8 centimeter. Now this is the long, folded, okay, folded. It become now 4, 5. Perpendicularly means, okay, 4 and 5. So what is the perimeter? 2 into L plus B. So 2 into 5 plus 4, 18. Okay, this is also very easy question, my dear friends. So based on the student data, only one question is difficult, one is moderate, remaining questions everything easy. Okay, according to the student data, my dear friends. These 3 questions we had that we are getting the questions from our sources. Okay, my dear friends. Next, continue mathematics. Aditya sir will take the class.
So students, from engineering mathematics, we received 5 questions. So let me discuss one by one. So there is one simple question from matrices where a matrix A was given like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 3 cross 3 matrix, and they asked what is the product of eigenvalues. So we all know the property that the product of eigenvalues is equal to the determinant of the matrix. So they asked what is lambda 1 into lambda 2 into lambda 3, which is nothing but determinant of A. So how quickly can you find the determinant of A? So you can do these operations like R2 is replaced with R2 minus R1, R3 replaced with R3 minus R1. Let's see what do we get here. So the first row is unchanged, 1, 2, 3. So this is 3, 3, 3. 7 minus 1 is 6, and then 6, 6. Now you can observe that the third row is 2 times the second row. So there is a dependency. Because of this, the determinant of A is 0. When the determinant is 0, the product of eigenvalues is also 0. So this was one simple question. In another question, so we don't have the proper data, so it looks as if it is a MSQ, multiple select question. So they gave something like this: the probability of A is 0.3, the probability of B is 0.5, and the probability of A intersection B is 0.1. So I think this is a MSQ question where you need to check what is P of A union B, what is P of A intersection B, what is P of A intersection B complement, what is P of A complement intersection B complement. So finding P of A union B is so simple. You can use addition rule, which is P of A plus P of B minus P of A intersection B. So this is the first calculation. So which is 0.3 plus 0.5 minus 0.1. This is 0.7. You can verify. And next, maybe they would have asked about the independence. So is this equal to this or not? P of A into P of B. Let us verify that. If this is equal, then they are independent. A and B are independent. So what is P of A intersection B? It is 0.1. What is P of A into P of B? 0.3 into 0.5, which is not 0.1. Therefore, A and B are not independent. So that is another option. And they also asked something like this: P of A intersection B complement. So this kind of data has been asked many number of times. So if you are good with the Venn diagram, you can easily answer what is P of A intersection B complement. So you can quickly draw. Let's say this is A, let's say this is B. So let us mark this is A, B. What is B complement? So can you check what is B complement? This is B complement. Let me use another color. So let's use white. So this would be B complement. So we need P of A intersection B complement. Now from this, you know B complement, you know A. What is their intersection? Clearly intersection is this part. This part. So how do you find it? We find it like this: P of A minus P of A intersection B. P of A intersection B. So you have all this data, like this is 0.3 and the intersection is 0.1. So this will be 0.2. So what's the next question? It is about P of A complement intersection B complement. You can rewrite this as, there's a formula here which is 1 minus P of A union B. So already A union B has been calculated. So if you can substitute that, so what would be the answer? It would be 1 minus 0.7, which is 0.3. So these were asked from the probability. Let's look at the another question. So they gave some data like this, something like 9, 10, 11, 11, 13, 14, 15, 17, 18 and 69. Some data values were given and they were asking what is the median. It's a very simple question. If you count, there were 10 observations. So what are the two middle observations? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these two are the middle observations. So the median is 13 plus 14 by 2, which is 13.5. So let's go to the next problem. So some data is given like this, like there are 10 red and 15 white objects, okay, maybe balls. 2 balls are drawn without replacement. The probability that second ball is red, given that the first ball is red. The moment you read this statement, that the probability that the second ball is red, given the first ball is red, so clearly it's a conditional probability. So there's already a condition given that the first ball is red. So when the first ball is red, you can remove that. So the reduced sample space will be like this. So there will be now 9 red and 15 white objects. So what is the probability the second ball is red now? So this is so simple, 9 by the total number of objects, which is 9 plus 15. So this is the answer for this question. Now along with this, there was one more interesting question where we did not receive the data properly. So whatever data we received, so we are explaining according to that. So the question says that there is a function called f of x, which is defined as maximum of x comma x cube. So the points where the function is not differentiable, this is was asked. Now this is clearly a linear function, this is non-linear function. I hope you better have a, almost all students will have an idea of how to draw x and x cube. So how does x look? So it's a straight line passing through origin. How does x cube look? So I'm just drawing a rough sketch. You need to find the intersecting points. So this will definitely guide you. So how do you find the intersecting points? For that, let us equate x with x cube. So this is same as x common x square minus 1 equal to 0. So the intersecting points are 0, minus 1 and 1. So it's like at these points the function may not be differentiable. You need to check that. So how do you check that? You can write the piecewise function now. So how do you write that? So let me just solve this. F of x. So what happens to the function for x less than minus 1? What happens to the function for in the interval minus 1 less than or equal to x less than or equal to 0? What happens in this interval? And what happens for x greater than 1? If you can imagine this, if you have an idea of this, you can easily answer. So for x less than minus 1, so to the left of minus 1, so obviously who is you can also find the derivative. You can solve. ఫస్ట్ నుంచి చెప్పనా ఈ ప్రాబ్లమేనా రెడీయా So looks like some issues with this problem. So let me repeat the data. So they gave a function called f of x equal to maximum of x comma x cube, and they're asking at what points the function is not differentiable. So what you can do is you draw x, which is a straight line passing through origin. So most of you also have an idea of how to draw x cube. So this is how x cube looks. Try to find the intersecting points. For that I have equated both of them. So I got the intersecting points as 0, minus 1 and 1. Try to draw the function. So what happens to the function for x less than minus 1? What happens to the function from minus 1 to 0, 0 to 1 and to the right of So looks like there is a issue, technical issue with the mic. So let me just summarize this problem. Let me give you the answer for this. So they gave a function called maximum of x comma x cube. So try to draw that. So this is how it looks. It's a piecewise function. When you try to find f dash of x, this is how it looks. Now if you try to find the left and right slopes at -1, 0 and 1, they will not be equal, meaning by the function is not differentiable at -1, 0 and 1. So this is what information we have. So finally let me summarize. So how many questions so far we received from engineering mathematics? We received 5 questions. So these 5 questions will be helpful for the tomorrow student, like whoever is appearing for EC and electrical, for them it would be useful. So there is a question on differentiability. There is a question on determinants and properties of eigenvalues. There is a question on basic probability. There is a question from statistics. There is also a question from sampling. So 5 questions we have received. So these are the solutions for those problems.
Hello, hi. So as for the source of information, on the TOC, we have received the total of 4 questions. This is the primary information according to the student feedback. There we have received about 2 questions on the numerical answer type, and 1 question is on the, we have it on the MCQ, as well as the one is on the MSQ. So this is the pattern we have received on the TOC. From the memory based questions, we have received the 2 in online, which we have received from our students. So I try to give the solutions for these 2 questions according to the available data, and we will going to be correct this one once the exact question paper is released. We are going to be touch upon all the options, and the questions will be thoroughly discussed. Whatever we are presenting the data here, it's according to the memory based data. So just look into the question number 1 here. This is the question on the regular expressions. So he gave here 2 regular expressions. One is R, other one is the S here. R and S, there are 2 regular expressions. We need to find it out. What is the number of strings of length 5 or less, not presented neither in the R nor in the S. So indirectly you have to determine here what are the number of strings up to length 5 not presented in the either in language of the regular expression R or the language of the regular expression S here. So if you look into this question, what you can understand, we have to determine about all the strings up to length 5. If you look at here, the alphabet of this regular expression, it is a 0, 1. If you see here number of strings of length up to 5, it is right from length 0, length 1, length 2, length 3, length 4 and length 5. Up to length 5, they are all possible strings here. So if you take this entire number, this is equivalent of 1 plus 2 plus 4 plus 8 plus 16 and then 32. So there are totally 63 number of strings are possible up to length 5 over the alphabet of 0, 1. And we have to determine here what strings are possible here, what strings are possible here, we have to determine. After that we have to subtract this number from this 63. so that you will get the exact answer how many you are going to be have it from this statement. So, if you look at here this statement of the R, it is a representing of any number of zeros or any number of ones. That is the language you can represent here. So, according to this statement, what do? You can have a epsilon here, you can have a 0, you can have a 1, and then length 2 strings can be this, or else you can have this. After that, length 3 can be about the double triple 0, or it can be the triple 1. Then if you take here length 4 can be either this or this. Then length 5 can be the last choice for us, so it can be up to this. And similar way, if you go for expansions of this expression, what strings you will get here? The first one can be either 0 or 1 here. Later on you can have here either length 2 strings are either 0 1 or 1 0. Further, what you can understand from there is a possibility of 0 1 1, it can be 1 0 0. They are the 2 more strings of length 3. Length 4 can be here 1 followed by here, this can be the 1 power 3, or else it can be 1 followed by this. Then you can have this, and one more question you can have here 1 followed by 4. So, they all are possible strings what you can generate from the expressions up to length 5. What is the common? So, if you look at here, these all strings you have to extract. If you see this combination, if see up to this point, you can see all the strings of length 2 up to length 2 are covered in this expressions. What you have got here? This is the 6 combinations. From here we have the 6 more combinations here. If you take the number of strings up to length 4, what do you get from here? This is going to be like from here 4, 2 plus 1, and then we got another 12 here. So, that way if we take number of strings from these 2 combination of the expressions up to length 2, you have here length 1 is there, length epsilon 0 also there, 2, then this is the possibilities. After that you got here 12 more strings. So, if you consider this all combinations, this is equivalent of the 19. So, finally what you can say, they all are the possible strings what you can have it from these 2 expressions, but we need to have here what are the strings are not there in this combination. So, that means which is equivalent of 63 minus 19, which is equivalent of 44. So, 44 is the right answer for this particular question. So, according to the source of data what we have. Then we move to the next question. This is on the expression, this is on the regular sets properties. Here they gave the 3 languages, L1 and L2 is pretty sure they are the regular languages, and L3 is not a regular language. So, these are the 3 statements what is given here, and we need to find out what is the true statement according to the given options. What is the true statement according to the given options? If you look at L1 and L2, they are regular languages, and we are all aware about what are the regular language closure properties. Regular languages are, they are closed under the complementation, they are closed under the union, they are closed under intersection, whatever may be the property, by default it is applicable for your regular languages. So, that is the reason you can understand L1 bar, L2 bar both are here regular, and its union is also regular. So, what you can say, the statement number 1 whatever you have, it is a true statement because regular languages are closed under complementation, L1 complementation is also regular, L2 complementation is also regular, and its union is also by default regular. So, that is a by default statement. And this is the one we are not aware about what is the L3 bar. L3 is not a regular, usually according to the De Morgan's formula and all, if you use it, this statement also can be treated as a true statement here. And we are coming to the statement number 3, what I mentioned, if and only if L and its complementation of L2 suppose made it as a pi, can I say always my L1 is equal to L2? Actually it is always subject to the what is the kind of languages we are using for the L1 and L2 is matter, because you have to look into the some of the examples where you can exactly figure it out. Although you have this is equivalent of the pi, there is no guarantee to have here always L1 is equal to L2 here. So that is why this statement cannot be true, it can be the false statement. For that, if you want to take examples, you can also take the examples and you can prove it. And this third one, whatever you have here, option D is telling about what is the L1 here and L3 here. L1 is regular, it is fine, but L3 is not a regular. What is the L3? L3 is not a regular language. When something is not a regular language, when I going to take here with respect to union of the L1, there is no guarantee to have the result as a regular here. So that is the reason this statement is also can be treated as false statement. So this is all possible solutions for this question according to the statements. So these are the source of questions we have received on memory based. So we will meet soon once question paper has got released from the institute.
Hi everyone. Let us discuss discrete mathematics questions. From our discrete mathematics, we got some 3 to 4 questions in our 2024 CSE gate paper. My dear students, let us discuss that 4 questions. If we analyze the paper, we have one question from functions concept. And we have one questions from graph coloring. On graph coloring, we have one question. I think that is our MSQ question, 2 marks question it is. And we also have one more question, algebraic structures. And we have some question on graph, some related to spanning tree. Yeah, we can treat that question as also in our algorithms or data structures, we can say. If we come to the pure discrete mathematics section, we have questions from 3 areas. My dear, the surprising thing this time is we don't have any question from math logic. So we don't have any question from math logic, and as it is, they maintain the consistency about what do you call graph theory. Every time from last 20 years onwards, whatever the consistency maintaining about graph theory, still it is there, but they touched what do you call functions concept, and surprisingly there is no question from math logic, and there is no question from what do you call combinatorics topic. Maybe in afternoon session we get the things. So after the updation we can update such things also. Let us discuss the questions. We have a question like this. From functions, we have the question like, let A and B are non-empty finite sets. Such that there exists one and onto function. There exist one and onto functions. One and onto functions from A to B. From A to B. It is just like first condition from A to B, and A cross A to A union B. My dear, understand here what we have is we have one function and onto function. So this word is very simple. It is just like and. But these type of simple words are very important in exam. You should be care of, right? So we have one function and onto function. So which means that the examiner is conveying that it is indirectly nothing but there is a bijective function. And you know that the bijective function is possible if and only if the size of the domain is same as the size of codomain. In that case only we can get the bijective function. I hope you remember the concepts. So which means that there is a bijective function from A to B means the size of A is same as size of B. Let us take that size as something like n. And in similar way, the size of Cartesian product A cross A, which is equals to the size of what do you call A union B. I think this area is perfect to you. A cross A means if there are n elements, in A, we have Cartesian product consists n square elements here. That's okay, fine. But the doubt rises here, what is A union B? Without having the information, we cannot decide what is the size of A union B. But let us suppose the range here, the size of A and the size of B is n, we know that. Let us suppose if A and B both are same elements, whatever the elements consist in set A, if the same elements are available in set B, in that case we have something like n elements are available. Because both are common, it consists only n elements. And in the same way, let us go for maximum case. Maximum case in the sense A and B both are disjoint sets. Whatever the elements present in set A, that element is not belongs in B. In that case, A, B elements are different. In that case, I think we have n here, n plus n elements. My dear, I hope you are getting this. This is min range and this is max range. So the possibility of n square is it can have two cases. N square is equals to n, this is case 1, and n square is equals to 2n, that is case 2. Let me take two cases. Case 1 is if n square is equals to n, then n value is going to be 1. If n square is equals to 2n, in this case, n is equals to 2, right? So the final question is, when there are one function and onto function exist from A to B and A cross A to A union B, the requirement is the size of A. So size of A is what we have considered, that is n. So the possible values of chord A consist. Let me write like this: the possible values of chord A. Yeah, this is one value and this is another value. Total number of possible values is 2. My dear, let me make one more point. I hope you know this. These are the questions based on memory actually. So if there are any changes in data, according to that we can update. Up to now, whatever the information we have, so about this question, the possible values are 2, right? Okay, fine, and let me discuss one more question. We have a question from group theory, algebraic structures we have. So A delta B is defined as A plus 2B, and another binary operation A square B is defined as A into B. So on these two binary operations, what they have defined is, we have different options, right? Option A is delta obeys associative law. And option B is operator square over delta obeys distributive law. And option C is operator delta over square obeys distributive law. And option D is the operator square obeys, what do you call, associative law. My dear, say this, in our algebraic structure, you know very well the heart of the question is nothing but the binary operation. If the binary operation is clear to you, then everything will be clear. If you have any doubt in binary operation, then we cannot solve this question. I think this is a simple question, we can solve it. I hope you remember associative laws, distributive laws, and what is in associative law, what do you say? Square over delta and delta over square, these things you know. Let me take the first point, that is associative law on delta operation. So if it follows associative law, it has to be something like this. I am discussing option A here. In option A, what I should do is A delta B, A delta B delta C should be equals to A delta B delta C, right? And delta is just like this. Delta is nothing but A plus 2B. Let me use this. This is A plus 2B delta C. And let me use this again. This is X delta Y in the form. then x plus 2y you can say, x plus 2y, 2c. This is my LHS answer. Let me take RHS part. Here we have a plus 2 b delta c actually. A plus, let me do in this way. Actually, the meaning of associative is we need to do bracket part first. So b delta c it is. Let me take b plus 2c here. After that operation, let me take delta again. So this is a plus 2 times of b plus 2c. Here I got some answer like this, a plus 2b plus 4c. So this is our LHS answer and this is our RHS answer. We can understand that the binary operation delta cannot follow associative property because both answers are different, right? That is our first option. And coming to the second option, in the second option what we are getting is the operator square over delta, right? The operator square over delta means we need to check in this way. So a delta, a square b delta is, b delta c is a delta b, a square b delta a square c. If it is holds good, then we can accept that this operator square over delta can follows this property. Let me do this. So here we have a delta a square, b delta c means b plus 2c we have, and this square operation is nothing but into x square y is nothing but x into y. So a into b plus 2c, yeah, ab plus 2ac. This is our LHS answer. Coming to the RHS, we have a square b here. A square b we can express as a into b delta a square c, a into c here. Now it is in the form of x delta y. Let me use delta operation again. So x plus 2y in this form. So ab plus 2 times of ac like this. So ab plus 2ac I got. My dear, if you say this, the LHS part is AB plus 2AC and the RHS part is AB plus 2AC and LHS is same as the RHS, which means option B is perfectly correct. Yes, the distributive property where we are using square over delta follows distributive property. So we can confirm that, we can confirm this statement is true, I can say. Let me put equals to here. Yes. We can say option B is correct. And moreover, in the same way, you can use delta over square also. If you take delta over square, that option is going to be false actually, right? A delta, B box C it is, and A delta B square A delta C like this, right? A delta B box C or B square C is nothing but BC, and A delta BC is A plus 2 times of BC. This is our LHS answer. And coming to this, A delta B here, A delta B is A plus 2B we have, and this is delta A plus 2C we have. Now again it is in the form of x delta y. We can take it as, x square y. We can take it as x into y. A plus 2b into A plus 2c. My dear, easily you can observe these two things are not equal. So LHS is not equals to RHS. That means option C is false here, right? Option C is not correct. Now coming to option D, here we have operator called square. Square obeys associative law. So the square operation, what square says, a square b is nothing but a into b actually. A square b is a into b. You know that multiplication follows commutative property. Yeah, if you take two real numbers, 2 into 3 is same as 3 into 2. So this multiplication follows what do you call commutative property. When the binary operation follows commutative property, definitely by default it can also follows what do you call associative property, isn't it? So what can I say is, when I see that a delta b is a into b, if I observe that that is multiplication, as we know that multiplication follows commutative, without solving the option, we can say the answer directly. Option D can also be correct. Is it fine, my dear? It is the MSQ question we have. It is for something like 2 marks. Coming to the solution to this question, both B and D are correct. Right? This is the question from what do you call our group theory. Yes, sir. After the group theory, we also have the questions from graph. In the graph, the question is like this. They given chromatic number. The chromatic number of a graph is k. It is possible on n vertices. On n vertices means the order of the graph is n here. And the different options we have, what is option A is saying, G contains complete subgraph with k vertices. G contains complete subgraph with k vertices. And option B is G contains at least k into k minus 1 by 2 edges, at least. And C is the graph G contains independent set of size at least n by k. And option D is the graph G contains vertex of degree at least k. Right? Yeah, these are the options. My dear, this is another MSQ question, and it is just like a traditional thing we can say. In every time gate paper, you can watch any gate paper, 2 marks question is compulsory from graph theory, and the tradition follows like this. And this is the question we have. The question is like this: chromatic number. So the minimum number of colors required when you are coloring the graph, we require colors. That minimum number of colors required for the graph such that edges and vertices should not have in the same color, right? So what I am saying is the chromatic number of the graph is k on n vertices if G contains a complete subgraph of k vertices. Either this is true. This is the scenario. You should understand the question in this way. So you see, complete subgraph means when you are taking the subgraph can be definitely complete. For example, if I take some graph like this, let me say something like Kn. In Kn, Kn minus 1 can be present. In Kn, Kn minus 2 can be present. Are my words are clear to you? If you have K5 graph, can you imagine K5? In K5, you can find K4. You can also observe K3. You can also observe K2, K1 also, right? For example, I have a K5 graph, complete graph on 5 vertices, just like this. Complete graph on 5 vertices. The first graph is neighbor to everybody. First vertex, sorry. And the second vertex is also neighbor to everyone. And third one also like this. And these are the 10 edges we got, right? These are the 10 edges. My dear, what I am saying is, this is a K5 graph, complete graph on 5 vertices. In this complete graph, if you observe something called 4 vertices here, one is neighbor to everyone, and the second vertex is also neighbor to everyone, and the third vertex also, and the fourth vertex also, right? Yes. I hope you are observing K4, whatever I highlighted here, that is K4, right? That is K4. It is a complete subgraph. So you see the given statement. In the given statement, what they are saying, G contains a complete subgraph with K vertices, then the chromatic number of the graph is K. What it means? For example, if the given graph is a K5 graph, K5 consists a subgraph with 4 vertices also, K4 also possible. But you are saying it is simply the subgraph, if it consists of 4 here, then the chromatic number is 4. That is not correct, huh? Right? I hope you should understand in a proper way. Somewhat a tricky statement it is. Here the graph name is K5 and the subgraph name is K4. This K refers to 4. Answer cannot be 4, right? If you color this graph, K5 graph, the chromatic number of a complete graph, Kn, it can be n, If you may have some complete subgraph, Kn minus 1, Kn minus 2, but they cannot be the answer, right? And coming to second area, G contains at least K into K minus 1, 2 edges. My dear, it is a famous statement and it is correct actually. When you have KC2 edges, definitely the graph can be, it is going to be chromatic number K. The example is, I think I can use the same example here. The K5 is there in front of you. The K5 consists K into K minus 1 by 2 edges here, 10 edges are available. So all 10 edges are there here, right? So in these 10 edges, then the chromatic number of the graph is, you can take like this. If you choose red color here, you cannot assign red here. You cannot assign red or blue. It should be something green. It should be yellow because it is adjacent to everyone, right? And it can be something like white color. So this is the reason I said the chromatic number of the graph is n. And the chromatic number of a complete graph K5 is equals to 5 like this. So in this scenario, what you are saying is K into K minus 1 by 2 edges are available at least. In that case, definitely the chromatic number can be K. You need to link the statement every time. So this can be true statement, my dear. And coming to the third case, G contains independent set of size at least n by K. I think this is also the famous statement. Famous observation. You can directly choose this. This can be correct actually. But I can give the analysis also. I don't take any simple graphs or anything. I can directly take the general way. For example, there is a complete graph Kn. You just imagine there is a complete graph Kn. For that Kn graph, what I am doing is, I want to find out the size of the largest maximal independent set, right? That is nothing but independent number. So if you ask me, the independent number of this is definitely 1, right? We are collecting the number of vertices. That vertices should not be neighbors at all. So when we are taking the Kn graph, this Kn graph, every vertex is neighbor to every other vertex. In that case, you cannot choose anyone. For example, if you choose one vertex, you cannot choose anyone because every vertex is adjacent to that one. Only the non-neighbors you can choose. So because of that reason, the beta value is going to be 1. This is one case. This is the first thing you should understand. And the second thing is, just now I said that the chromatic number of a Kn is nothing but n, right? My dear, understand carefully. N by K, in the given statement N by K, N indicates number of vertices and K indicates chromatic number according to the given data. What I am saying now, the given graph is a complete graph, so there are n vertices, no change here. But whereas coming to K, K is nothing but a chromatic number, right? So n by chromatic number of this is n. So n by n, which is exactly equals to 1, this 1 is matched with this one. So this statement is perfectly correct, my dear. Not like a simple examples, C3, C5 or anything. You can directly take the generalization. You can visualize the complete graph. It is already in front of you. You can see like this. Okay. Next, coming to last statement. G contains a vertex of degree at least k. So what is the reason? What is the at least k means? I think you are speaking about min degree. If min degree is k, then the chromatic number is k. So how it is possible? I want to take a something like cycle graph. Let us suppose some cycle graph here. Cycle graph here. The chromatic number of this cycle graph C3 is red, blue. I cannot assign red here, I cannot assign blue here, I can assign something called green here. Then the chromatic number of C3 is equals to 3 something. You just see this example and read this statement again. If G contains a vertex of degree at least k, my graph is a regular graph, moreover cycle graph and min degree and max degree both are same, that min degree and max degree is 3, right? Sorry, min degree and max degree is 2. Min degree and max degree is 2. If min degree and max degree is 2, if that is k, according to the given question, it must be equals to 2. Chromatic number must be equals to 2. But my chromatic number is 3 here. This is the counter example for option D, my dear. So D is also not correct at all. So what we can confirm? We can confirm option B and option C are the correct answers to this question. These are the some 3 questions we got from what do you call our discrete. Yeah, let us see. We have taken a one question on functions. So that is something like what do you say? On number of functions, what is the min size? The size range we got like possible values 2 here. It is NAT type question. And the second question from group theory and the 2 on distributive property we got it on basic operations. Moderate question it is. After that we got some level question from graph theory, 2 marks question. Yeah, 2 marks question. This is also MXQ, previous one also MSQ. And before that one, first question is just like NAT type question. And one more question also we have, some question we got something like this. The number of spanning trees. The number of spanning trees on 4 nodes. Right? My dear, this is a direct question actually. The number of spanning trees, we have a formula that is n power n minus 2, n rise to n minus 2. We have 4 nodes here. If we have 4 nodes, 4 minus 2, and it is a 4 square, some 16 spanning trees we can construct. Yeah, we have a spanning trees. In that spanning trees, maybe some spanning trees are isomorphic. And in that spanning trees, we may have minimal spanning trees. All this discussion we have, we are just, we are taking spanning trees. And this question we can count in data structures also. This is a question which is common in our both discrete and our DS. So, yeah, that's about students. That's about our discrete mathematical structure discussion. Yeah, thank you.
Hi, hello everyone. Good evening to all of you. So now we are going to see operating system related questions. See, from operating system, we have total only 5 number of questions, but not 6 questions. One question is from secondary management, which comes under COA part, but not on OS part. So by considering that from operating system, we have total 5 questions. Among the 5 questions, we got 4 questions. Among the 4 questions, we are going to discuss now. So as part of the 4 questions, the first question, which is related to thread management. So coming to the threads, so considering the threads, which of the following is true? Threads belongs to a same process are by default not protected by each other. And option B, each thread has its own file descriptor. Option C, threads can only be implemented in kernel space. And option D, all threads belongs to a process has its own stack. So if you consider your multi-threading concept, so try to recall our multi-threading process diagram. So if you consider this is my code section, this is my text section, let's say this is my data section, okay, code section, data section and file section. And assuming that this multi-threaded process, this is my multi-threaded process, okay. I am considering that there are 3 threads in this particular multi-threaded process. So these are the 3 threads I am having. So this is my thread 1, this is my thread 2, this is my thread 3. So by considering this diagram itself, you can filter the options here. So what is the first one? All threads belongs to a same process has its own stack. Verify. If you consider here, this is my thread 1, thread 2, thread 3. Every thread can have its own stack pointer, its own program counter and its own register set. Same, this thread is also having its own stack pointer, its own program counter and its own register set. In the same way, here also stack pointer, program counter and register set. So if you can consider this diagram, so option D is true here, right? Option D is true. All threads belongs to a same process, has its own stack. See, look at thread 1 is having stack pointer, stack, right? So hence I can say option D is true. Then coming to option C, threads can only be implemented in kernel space. Recall classification of threads. So coming to the classification of threads, we know that the classification of threads is 2 types. One is called user level threads, another one is called kernel level threads. What does it mean? Kernel level threads are being implemented by the kernel, which means in the kernel space. User level threads are implemented by user in user space. But what is the option it is mentioned? Threads can only be, this is what the word which you have to pay attention. Threads can only be implemented in kernel space. No, this is false, right? Because threads can also be implemented by the user, means in the user space, as well as in the kernel space also. So hence you can say that option C is wrong here. Then coming to option B, each thread has its own file descriptor. But look at the diagram here, file section if you consider, it is common. But here it is mentioned that its own file descriptor. Hence, this is also wrong. Then coming to option A, threads belongs to a process are by default not protected by each other, which is true. Because we need some extra mechanism in order to protect the threads here. So that's why this is true. So overall, the answer for this question, we can say that both option A and D. So this is the explanation and the corresponding key for this question, right? Then coming to next question. So which of the following state transitions is or not possible? Look at not possible, okay? Option A, ready to waiting. Option B, running to ready. Option C, running to terminate. And option D, waiting to running. So this question seems, very easy, but little contradictory question I can say. Reason, as per the Galvin textbook, if you can check it as per Galvin textbook, recall the 7-state diagram. So whatever we have discussed in our classes, 7-state process diagram, if you recall. So there we clearly mentioned we clearly mentioned ready to waiting. See, this is what my ready state, this is what my ready state, this is what my running state, and this is what my waiting state, and this is what my exit state, right? So we clearly mentioned while we are explaining in our classes, we clearly mentioned that there are some valid transitions, there are some invalid transitions. So first I am point outing the valid transitions. Running to exit is a valid transition, means it is possible transition, that is what, so hence this is possible, right? Running to termination is possible, but the question is speaking about not possible, okay? So hence this is not an answer for this question. Then running to ready, this is also possible transition. You know that when there is an interrupt or else timeout is occurred, then this transition is possible, right? So which is preemption kind of stuff. So running to ready, which is possible. Running to ready, it is possible, right? So, but the question is speaking about not possible, hence option B is also not answer for this. Then coming to, you can say that ready to waiting. Ready to waiting, if you see this, ready to waiting, actually we have waiting to ready, right? As per Galvin textbook, we have waiting to ready. But there is a possibility that ready to waiting is also possible. When it is possible, when there is a resource preemption case is being considered, when there is a deadlock, or else when there is a high priority process is there, which is requesting one resource which is currently held by some low priority process, then since the high priority process is being requested, the resource which is currently held by the low priority process, then what operating system will do, it will preempt that resource from the lower priority process which is currently in running, currently in ready, and it can hand over to higher priority process. So in that context, you can say that the lower priority process can move from ready to waiting, right? So there is a possibility for this transition also, but we mentioned that this is undesirable transition. So if you consider Galvin textbook, we can go with waiting to running is not at all possible. Waiting to running is not at all possible. So since the question is speaking about not possible, option D is the answer here. And ready to waiting, as per the Galvin textbook, ready to waiting was not there. So that is, hence we can say this is also an answer for this question. A and D are the answers for this question, but we can challenge this question like there is a possibility for ready to running also, ready to waiting also. There is this is a possibility for challenging, okay? Question seems very easy, but little analysis is required in order to answer this question perfectly. So as per the Galvin standard textbook, I can say A and D is the answer here, okay? Right. Then coming to next one. But mind that I am telling you guys, this is also possible, this is also possible, okay? This is also possible, right? Then coming to this question. So this is from memory management concept, simple paging concept. So consider a memory management system with the page size of 2 KB and the page numbers are 0, 1, 2, 3 are stored in frame numbers 1, 3, 2, 0 respectively. If the given logical address is 2500 in decimal, then what is the physical address in decimal, right? So the question is saying that page size is 2 kilobyte. So page size is 2 kilobyte. 2 kilobyte, which I can also call it as 2 power 11 bytes. Okay, 2 power 11 bytes. Right. Then the page numbers. Look at this line. This is the main statement of this question to solve. Okay. The page numbers 0, 1, 2, 3 are stored in frame numbers, means the page table information is given here. This is my page table. So in this page table, this is my, you know that page number is the offset to the page table, frame number is the entry of the page table, it is the element of page table entry, right? And this is the index. So here the page numbers are what? 0, 1, 2 and 3. And these pages are stored in these frame numbers. What are the frame numbers? 1, 3, 2 and 0. Okay. So this is what the table here, page table information here, and this is the page size here. Now the question is given logical address which is in decimal format, 2500 is the logical address. So logical address is given 2500. So what you can do, convert this logical address into binary. So if you convert this logical address into binary, look at for example 2500 in the sense 2 power 10 is 1024, 2 power 11 is 2048, right? So which I can say that I am going to consider 11 bits, I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, right? So this is my 2 power 0, 2 power 1, 2 square, 2 power 3, 2 power 4, 5, 6, 7, 8, 9, 10 and 11, okay, right. So 2 power 11 I required, so that I am setting it 1. So 2 power 11 is what? 2048. Then 2 power 10 is not required to me because it is exceeding 2500. 2 power 9 also not required. Reason, if I add 512, it is also crossing 2500. So then I required this one, 2 power 8, which is 256. So then this is 2204. So this is I am setting to 1. And 128 is also required. Then it is 2332. So 128. Then 64 also required. 2396, right? And so this is also I am setting to 1. And 2 power 5, if I set 32. So see, I just telling you clearly, logical address is 2500. If you write this in binary, 12 bit you are getting here, right? So up to 0 to 2 power 11, we are getting these number of bits. Among these 11 bits comes under your offset, right? You know that logical address is being divided into two parts. One is page number, another one is offset. Offset is what? What is the page size here? 2 power 11. So this is considered as offset. So 11 bits among this logical address, after converting this logical address into binary, whatever the 11 bits we are having here, these 11 bits we are considering as offset. And remaining 1 bit we are considering as page number. So for example, if you consider page number is 1, let's say this is page number 1. So what is the page number 1? This is page number 1. What is the location of this page number in the main memory? 3. What does it mean? So these 11 bits are as it is here. This is my physical address, okay? These 11 bits are as it is here, and page number is, this page number is being stored in 3. 3 is what in binary? 11. So why it is 11? As I mentioned that here you are having 4 frames, as the question is clearly mentioned that 4 frames are there and 4 pages are there. So if you have 4 pages, which means that you require 2 bits in the page number field, right? So that's why I am considering these most 2 significant bits are the frame number and remaining all the offset. So if you consider this paradigm, at the end you are going to get the answer like 6596 you can get, okay? So this is the way how you can solve this question, right? So conversion may take more time, that's why I just giving you the idea how to solve this question, right? Next, coming to this question. So this is from inter-process synchronization. What are the possible values of A and B? So this is my thread 1 and this is my thread 2, or else process P1, process P2. Initial values of A and B is equals to 1. So the question, we can execute this 2 threads or else 2 processes either in terms of non-preemptive or else in terms of preemptive also. First, what I am considering, non-preemptive case I am considering, non-preemptive. So if you consider non-preemptive case, so first I can complete the thread 1, completely I can execute thread 1. So what is the A value, B value initially 1, so that now the A value is 2, B value is 2. Then I am coming to thread 2. So after thread 1 is completely executed, then I am coming to thread 2. Then B is equals to 2 into 2, which is B is equals to 4. And A is equals to A into 2, 2 into 2 which is 4. So A is equals to 4 and B is equals to 4. If I execute these two threads in this order, I am getting A and B both are 4. Next, in the same non-preemptive case, I am considering one more possibility. What is the one more possibility? So first I can execute thread 2 and then I can execute thread 1. Okay? First I can execute thread 2 and then I can execute thread 1. Right. So first I am going to execute thread 2. So coming to the thread 2, B is equals to 2 into B. 2 into B, B is what? 1. So that B is equals to 2 now. And A is equal to A also 2. So first I am executing thread 2. That is what my execution order. Please follow. Okay. Then I am moving to here. Then A value is 2. So that now A value is 3. And here B value is 2. So that now it is overwriting B value is 3. So what is the possible values of A and B now? A is equals to 3 and B is equals to 3. So A is equals to 3 and B is equals to 3. With this order if I execute. Then in preemptive case, so first you can execute thread 1 and then you can execute thread 1 first statement you can execute and then you can go to thread 2, execute both the instructions of thread 2. After that again you please come to thread 1 second instruction. So if you execute this order, so what is going to be happen? Have a look. So check now. So for example, so first what I am doing here, I am executing thread 1 first instruction. What is the A value? A is equals to 2 now. After this I am executing thread 2 completely. I am not executing the second instruction of thread 1. This is what the meaning of preemption, right? So now B is equals to what? B is equals to 2 only because B is not yet modified here, right? It is not modified, right? We have not yet executed this one. So now B is equals to 2, okay? Then what is the A value? A value is 2, now A value is 4, right? After that now I am coming to here. So the final value of A is now 4. Now I am coming to this one, now I am executing this B is equals to B plus 1 execution. So what is the B value? 2. So now what is the B value? 3. So A is equals to 4 and B is equals to 3 is the another possible values of A and B with this order of execution of these two threads. Then this is what my first case in preemptive. Then coming to the second case in preemptive, what I can do, first I can execute thread 2 first instruction, then I can take preemption to the thread 1 first instruction, then I can execute thread 1 second instruction also, and then I can come back to thread 2 second instruction. So this is the order if I follow. Even if I follow in this order, I am going to get the final values of A is going to be 4 and B is equals to 3. So overall, wherever, in whichever options, so since we have not having the options, I am clearly telling that in whichever option you are finding A is equals to 4, B is equals to 4, A is equals to 3, B is equals to 3, and A is equals to 4 and B is equals to 3. Whichever option you are having, that option is going to be the answer for this. Okay? So this is what another question we have from operating system. So this is what the discussion about operating system questions. I hope you are clear with them. Thank you.
Hello viewers, welcome to GATE 2024 CSE paper analysis focusing on algorithm and data structure subjects. As per my analysis point of view, the level of paper is moderated to difficult. So most of the students they are thinking it might be easy paper, but as per my analysis it is moderate to difficult. Okay. So let me see what are the questions they asked in data structures and algorithm subject. The first question based on sorting algorithm. Based on sorting algorithm. In online class, in offline class, I usually suggest 3 topics in algorithm subject. One is sorting algorithm, another one is heap tree, another one is spanning tree concepts. These 3 concepts are very important concepts. Every year they are asking questions from those topics, right? So this year also they asked 3 questions, one from sorting, one from heap and one from spanning tree, right? Look at this question, friends. Consider an array of size n, check whether array is sorted or not in only one pass. In only one pass. By comparing with the one element with the next element, means by comparing adjacent elements, we need to decide whether array is sorted or not. Generally, this algorithm we discussed in the class, right? I hope you remembered bubble sort algorithm process, okay? Let me explain some pseudocode how this algorithm is working now. So, if you consider bubble sort algorithm, where we are passing an integer array which contains exactly n elements. Just we are passing an integer array which contains exactly n elements, and inside this algorithm we are taking 2 local variables I, j, and also we are taking one flag variable here. Okay, this I variable useful for running number of passes. Okay, so here we are running passes like for I is equals to 0, I less than n minus 1, I plus plus, okay. And next for loop is useful for comparing adjacent elements. So j is equal to 0 and j less than n minus I minus 1 j plus plus, right. Now we are performing comparison like this. Suppose if a of j is greater than a of j plus 1, means we are performing comparison between 2 adjacent elements. If this condition satisfy, we can swap those 2 elements. Okay, here inside we can write swap code here. Swap a of j comma a of j plus 1. Clear, friends? A of j comma a of j plus 1. Here I'm just writing only pseudocode of the program for understanding the answer for this question. Look at this program. When I is equals to 0, this loop is running exactly n minus 1 times. Then how do you decide whether array is sorted or not in only one pass? Pass means here with respect to I variable. Okay. Now what I will do, when I is equal to 0, when we enter into this algorithm, here I am initializing flag variable is equals to 0. I am initializing flag variable is equal to 0. Right. When I equal to 0, it is starting from 0 to up to n minus I minus 1 here. After completion of this, if this condition satisfied, clear, if a of j greater than a of j plus 1, change the status of flag variable. Okay. By changing status of flag variable here, flag is equals to 1 like this, right. So after completion of this loop, before incrementing the I value, you have to check the condition like this. If flag remains 0, then break the algorithm, right, and then close the brace like this. Please observe how this algorithm is working. When I is equal to 0 in the first pass, we are performing n minus 1 comparisons, right. In these n minus 1 comparisons, if any one of the comparisons satisfy this condition, then we can change the flag status. If none of the comparisons satisfy this condition, flag remains 0 only. If the flag remains 0, then you no need to increment I value, simply apply break statement, we will come out of the loop. So for example, if array contains sorted elements like this, 10, 20, 30, 40, 50. There are 5 elements are there, which is already sorted. Now when I is equals to 0, right, when I is equal to 0 is the first pass, it is the pass number 1. J is starting from 0, friends. J is starting from 0. This is called pass number 1. This is called pass number 1. When I equal to 0, that is called pass number 1. So when j is equal to 0, now compare these two elements. If a of j greater than a of j plus 1, means a of 0 is greater than a of 1. So imagine it is 0th index, it is first index, it is second index, it is third index, it is fourth index. Now you are performing comparison between 0th index and first index. Verify is 10 greater than 20, is 10 greater than 20. A of j greater than a of j plus 1 means 10 greater than 20, condition false. Since condition false, we cannot execute this loop, we cannot execute this block. Then j get incremented now, right? If j get incremented, j becomes 1, right friends, okay? J becomes 1, and initially what is the flag variable? Flag variable is 0 only. Initially flag variable is 0. Now since j equal to 1, it will test the condition. If a of 1 greater than a of 2, means it is comparing between 20 and 30. 20 greater than 30, so the condition fail. Since the condition fail, we cannot execute this block of the statements, and there is no change in the flag status, right? After j get incremented now, so now j becomes 2. Now comparison between a of 2 and a of 3. So a of 2 means 30 greater than 40, 30 greater than 40 condition fail. Since the condition fail, there is no updation in the flag status, right? Then j get incremented now, j becomes 3. Now comparison between third element and fourth element, right friends? So when you take third element, fourth element, 40 greater than 50, condition false, right? Condition false. So if the condition false, flag status is not updated. Now j get incremented now, j becomes 4. Now test the for loop condition here. J value is equals to 4 and n means number of elements, right? How many elements we are having? 5 elements. So therefore 4 less than 5, I starting value is 0, right? So 0 minus 1. Now 4 less than 4, 4 less than 4 condition fail, then it will come out of the j loop. Once it come out of the j loop, now it will check the condition before incrementing I value. Now check if flag is equal to 0, yes, still flag is equal to 0. Since flag is equal to 0, it indicates that array is already sorted. Therefore, because of this break statement, I will not be incremented. I will not be incremented. Therefore, this algorithm run only one pass. In one pass, how many comparison we made here? Just look at here. It is the first comparison, it is second comparison, it is third comparison, it is fourth comparison, right? In one pass, we perform 4 comparisons, 5 elements. If there are 5 elements, 4 comparisons are required. If there are n elements, n minus 1 comparisons are required, right friends? So therefore, it is deciding only one pass, by taking how many comparisons? N minus 1 comparisons. Therefore, the time composite for this one is, it is theta of n minus 1 comparisons. But theta of n minus 1 can also be written as theta of n, right? Theta of n. The moment if you write theta of n, it is also satisfying omega, it is also satisfying order notation. Therefore, answer to this question is theta of n is correct, and order of n is correct, and also omega of n is also correct. So based on the given options, you have to select minimum time is omega of n, maximum time is order of n, and average time also theta of n. Clear friends, okay? So answer to this question is order of n is correct, omega of n is correct, and theta of n is also correct. This is the one question based on sorting algorithms, okay? Now look at next question friends. Yeah, so look at this question based on heap algorithm, right? So they provided elements like starting from 82 up to 93, right? So they're applying heapified algorithm. Now the question is looking at the first 3 elements in the heapified array, means after applying heapified algorithm, it is converted into max heap. If it is converted into max heap, what are the first 3 elements in the max heap? Actually, based on these options, this is very easy to evaluate friends, okay? I don't know really did they ask a question like this or not, okay? Because actually for answering this question, you no need to apply any algorithm, directly we can eliminate the options, okay? So how we are going to eliminate the option C? In a max heap, max element always at the root position, max element always at the root position. In such case, in this array, what is the max element here? 131 is the max element. Therefore, first max element is 131, right? If the first max element is 131, here it is 131, here also 131. But we cannot get 82, we can directly eliminate this option. And we can also eliminate this option, right friends? Now look at second one, second element is 11. Actually in this array, that is the smallest element in the array, right? But in the max heap, smallest element always available at leaf level. Smallest element always available at leaf level. Therefore, there is no possibility to get second element as 11. Therefore, the answer to this question is option B. Right? Option B is the correct answer. By elimination process, I answer this question. If you want, you can apply heapify algorithm also. Alright friends, okay? Now, let us move to the third question. Yeah, it is straightforward question based on DFS algorithm, friends, okay? Look at this one. The number of edges present in the forest generated by DFS traversal of an undirected graph with 100 vertices, right? So, total number of vertices, if I indicate it's n, that n is equals to 100 here, right friends? And how many number of edges are there? Number of edges are 40 edges, okay? Number of edges are 40 edges. Generally, DFS tree contain only 3 edges. DFS tree contains only 3 edges, okay? So, number of edges we are having, suppose if I consider number of edges are, if I consider is k is equals to 40, right friends? Now, they are asking how many number of connected components are there, clear? So, there is a property which is related to DFS algorithm and which is providing relationship between number of vertices and number of edges and number of connected components. So, the formula for this one is simply we can take n minus k. So, here it is 100 minus 40, so the answer to this question is 60. Answer to this question is 60 friends, okay. So, this question based on DFS algorithm, alright. So, let me explain next question. So, this question related to graph theory as well as greedy method algorithm. I think one of my friend Vamsi sir already discussed this question, right. The total number of spanning trees are possible in a complete graph with n 4 vertices, labeled vertices, okay. So, n to the power of n minus 2 is the straightforward formula friends, okay. So, n to the power of n minus 2 it is straightforward formula that equals 4 to the power of 4 minus 2 that equals 16 spanning trees, okay. Or else you can also take the complete graph they mentioned, right. Look at here, number of spanning trees are possible in a complete graph with 4 vertices, right. If the number of vertices are 4, then spanning tree must contain, spanning tree must have 4 minus 1 that equal 3 edges, right. This is the property you need to remember. Number of vertices are 4, number of edges in the spanning tree must be 4 minus 1, 3 edges. But in a complete graph with 4 vertices, how many edges we are having, okay. In a complete graph 4 vertices you can do it k4, right. In a complete graph 4 vertices, number of edges we can take it is equals to 4 into 4 minus 1 by 2, right. So, which is equals to 6 edges are there, friends, 6 edges. But your spanning tree requires only 3 edges, therefore, out of 6 edges you need to choose 3 edges, right. So, out of 6 edges you can choose 3 edges. After choosing 3 edges, those 3 edges do not form any cycle because your spanning tree do not contain any cycle, right. Therefore, we should remove number of cycles formed by using 3 vertices, 3 edges. Number of cycles of length 3. Number of cycles of length 3 like this, okay. So, number of cycles of length 3 means just consider complete graph with 4 vertices, you can understand. Suppose if I consider V1, V2, V3, V4, right friends. Now 63 value is equals to 20. We want to subtract number of cycles of length 3 because spanning tree do not contain cycle. How many cycles of length 3 are possible here? Just look at here. This is one cycle, right. This is one cycle of length 3, correct. That is one cycle of length 3. And the second cycle, this is a second cycle of length 3, alright. And similarly, it is third cycle of length 3 and it is a fourth cycle of length 3. Total, there are 4 cycles of length 3. Therefore, you can subtract 4 here. So, answer to this question is that equal to 16. If you forget the formula, you can apply this process, okay. So, this question based on spanning tree, friends, okay, which is related to discrete mathematics as well as algorithm subject, okay. I hope you answer this question very well, right. Let me discuss next question. Yeah, it is also based on heap tree concept. See, this year they asked 2 questions from heap tree because heap tree is very important topic in data structures. Look at here, friends. They are asking it is a mini heap which contain 105 distinct nodes. There are no duplicate elements. There are 105 distinct nodes are present. Then, what is the possible values of index on which maximum element is present? They are talking about index value where the maximum element is present. Okay, they are talking about index value where the maximum element is present. Remember friends, in a min heap, max element always present at leaf level. Max element always present at leaf level, right? So therefore, in a heap with n nodes, leaf node index starts from floor of n by 2 plus 1 and ends with n. This property, stride property, I provided in the class notes. Okay, just refer my class notes, you can understand. Leaf node index always starts from floor of n by 2 plus 1 and ends with n. Right? In this example, what is n value? N is equals to 105. Right, friends? If n is equal to 105, leaf node indexes. What are the leaf node indexes now? Leaf node index starting from floor of 105 by 2 plus 1. Right, it is starting from floor of 105 by 2 plus 1 and it's ending with up to where? Up to 105. Because it is starting from floor of n by 2 plus 1 and ends with n, so therefore it is starting from this place and that place. Floor of 105 by 2 means it is nothing but 52, right? Floor of 105 by 2 means 52. 52 plus 1, the result equal 53. So therefore, leaf node index is starting from 53 and ending at 105. Clear, friends? Leaf node index is starting from 53 and ending at 105. Now in the interval, if you consider in the interval a comma b, right friends, in the interval a comma b, the number of elements must be b minus a plus 1, right? In the interval a comma b, number of elements must be b minus a comma b minus a plus 1. Therefore, in this interval, how many elements we are having? That is 105 minus 53 plus 1, right? This is equivalent to 53. Therefore, possible index for the max element must be 53 indexes are possible. Because max element always available at the leaf level. Leaf node indexes, how many indexes are there? 53 indexes are there. Therefore, max element is present in any one of the 53 indexes. Clear, friends? So that is the answer to this question. I think it is a numerical answer type question. Okay. I hope you answer this question, right? Let me check next question, friends. This is based on programming concept, okay? I don't know whether really did they ask the question like that or not, because this question is very simple, okay? Let me explain what are the options they provided. They provided program like this and they provide options like this. It is printing some value A, B, C, D like this. As per the information we got from the students, they are saying that it is output of this program is 6, output of this program is 3, output of this program is 9, and output of this program is infinite loop like that they mentioned. Okay. So these are the options we got from the students. So based on this analysis, if you observe this program, initially a value is equal to 6, friends. Okay. Let me take the a value. A value is equal to 6 and b value is equals to 0. Right. Now it will test the condition a less than 10. Right now a is equal to 6, 6 less than 10, condition true. The moment condition true, we need to execute block of the while loop statement, right? Then a equal to a by 12 plus 1. Right now, so a is equals to a by 12, a means here 6, 6 by 12 plus 1. Obviously 6 by 12 will be converted as integer value, that is nothing but 0. Because here we are having integer variable, right? So 0 plus 1, result of a becomes 1. So a is updated as 1, right friends? Afterwards a is equal to a plus b. It is called compound statement, which we can write it as a equal to a plus b like this. So right now a value is equals to 1 and b value is equal to 0. So result of this expression is 1. So again a updated as 1. Now since it is a while loop, again control will go back to the previous state. Now it will check the condition a less than 10, a less than 10. Obviously a equals to 1, 1 less than 10 condition true, therefore again we enter into the loop. Then a is equals to a by, a means 1, a by 12 plus 1. So 1 by 12 means obviously 0, 0 plus 1 that equal 1, again a will be updated as 1, right friends. Afterwards a equal to a plus b, again 1 plus 0 that equal 1. So what did you notice from this? every time the content of A remains 1 only. If every time the content of A remains 1, this while loop condition always true, right? There is no choice to terminate this while loop. Therefore, based on the information, this program is generating infinite loop, friends, okay? Based on the given information, that program will generate infinite loop, right? So, next question. It is direct question from the class notes, friends, okay? You just open divide and conquer technique notes, class notes. These are direct question from the class notes which I explained, okay? So, let me explain what is the correct process for solving this question. They provided T of n is equals to square root of n into T of square root of n plus n. So, there are many approaches we can do this problem by using substitution method, by using change of variable like this. I will take simple approach, friends, okay? I will take simple approach for solving this question. What I will do, simply divide, okay, divide with n on both sides. Clear? Simply divide with n on both sides. By dividing n on both sides, we will have T of n by n is equals to root n by n, obviously it is square root of n. Therefore, T of square root of n by square root of n, because the moment if you divide with n, square root of n by n, that equals to 1 by root n plus 1. So, it is transforming like this, okay. So, now what you will do, you can consider something like T of n, like you can take S of n is equals to simply T of n by n, okay. You are simply changing the variables like this, S of n equal T of n by n. So, the moment if you change, this equation will be converted as S of n is equals to, so T of root n by root n can be written as S of root n, right, S of root n plus 1, because after all it is a constant, we cannot change the constant value, right, okay. Now, if you solve this equation by using recursively substitution method, observe the first iteration. If I go to next iteration, just try to understand. If I go to next iteration, it can be written as S of square root of n, right. So, square root of n, see there is no change in 1, we can write 1 as it is only, we can write 1 as it is only, but this part will be written like this, okay. It is something like, if you have T of some diagram, we can write T of same diagram under square root plus 1, correct, same diagram plus 1, right. So, by using that condition, this can be written as S of square root of n plus 1, right, plus 1. But this we can rewrite this statement as n to the power of 1 by 4, n to the power of 1 by 4. So, therefore, by modifying this condition, we can also rewrite this statement as S of n to the power of 1 by 4. 1 by 4 can be written as 1 by 2 square plus 1, 1 by 2 square plus 1, okay. So, if you observe here, and S of n to the power of 1 by 2 square plus 2 times of 1 added, right, 2 times of 1 added. If I go to one more iteration, it becomes S of n to the power of 1 by 8, 8 can be written as 2 power 3, 2 power 3. Then one more plus 1 will be added here, and these two ones we can write as it is, plus 1, right, correct, friends. So, now what did you understand? It is n to the power of 1 by 2 power 3. If you are having 3, we are getting 3 ones are accumulated here. If you are having k ones are accumulated here. Therefore, in the general format of this statement, we can write like this. By continuing this one, S of n is equals to, can I write like this, S of n to the power of 1 by 2 to the power of k plus how many ones added here? K ones will be added. So, therefore, we can take it as k, because k times 1 are accumulating. Now, this is the base condition. In this problem, we need to equate to this base condition with 2, okay. So, this value must be equal to 2. By taking that value equal to n by 2 to the power of k is equals to, it is 2. So, we can write it as 1 by 2 to the power of k is equals to log 2 base n, log 2 base n. By taking reciprocal of this, right, by taking reciprocal of this, we can write 2 power k is equals to log n base 2. From this k is equals to log base 2 of log n base 2, right. So, now substitute this k value back into this equation, substitute this k value back into this equation. Now, this equation will be modified as like this, S of n is equals to, whatever this value you have taken, 2, right. So, therefore, S of 2 plus what is the value of k, that is log base 2 of log n base 2. So, we can consider it as log base 2 of log n base 2, log n base 2, right, friends, okay. But S of 2 value is nothing but base condition that equals to 1 in this algorithm. Therefore, S of n is equals to 1 plus log base 2 of log n base 2. But what is S of n value, friends? Look at here. You are taken substitution S of n equal to, see here, S of n is equals to T of n by n. Therefore, substitute here that value. S of n means T of n by n, which equal 1 plus log base 2 of log n base 2. Now, I want the value of T of n. Now, take cross multiplication of this. If you take cross multiplication, then T of n value is equals to n plus n into log base 2 log n base 2. Right, friends? There is no space. Maybe it looks like clumsy, but please try to understand. It is n log n2. You know that when comparing the growth rate of n log n, we can ignore the growth rate of n. Therefore, this total value is bounded by theta of n log n. Because when comparing the growth rate of n, when comparing the growth rate of n log n is negligible. Therefore, this is bounded to theta of n. Right? So, answer to this question is theta of n into log n. Clear, friends? So, these are the varieties of questions came in algorithm and data structures questions. I hope you did everything is right. Okay. So, please stay tuned to AS Engineering Academy. Okay. Thank you so much. Now, my friend will discuss remaining questions. Okay. Thank you.
Hello. Hello friends, welcome back. Again we got two more questions on the TOC. These two questions are here. Numerical is one, other one is about MSQ. And this question, whatever I just posted showing on the screen, this is numerical answer type. This question is on the CNF. E given the string which length is equal to a power 30, b power 30, c power 30, that is all indicating about this is the string of length 90. Is asking us to derive the string of this W, how many number of productions you are applied, or how many number of steps you are applied to get the answer. So that is the answer he has been asking from this question according to the student information. This is a straightforward question. I would say here there is a direct formula which you can use to substitute the value and you can generate the answer directly from here. So you know that the string whatever is there, this is the W of a power 30, b power 30, c power 30. What does mean here? The string whose length whatever you have here, this is equivalent of 90. So this is the string length which is equivalent of 90. You know that in a CNF notation to derive the string of length n, we always required 2n minus 1 number of steps here. So you know that this is always the direct formula, it is equivalent of 2n minus 1 number of steps here. So according to this one, your capital N value is this one here. You can substitute the value here, this is equivalent of 2 into 90 and minus 1. So this is 180 minus 1. So you will be getting about 179 number of steps you have to be applied to produce the answer. So if they are asking for the length of the derivation to produce the string of length W what is given in the screen, if it is the exact data, then you would get here the value which is equivalent of always straight 179. This is the direct answer, you can say that. After that, there is one more question on the theory of computation. Just move on to the next question here. Let us see, this is the direct question on the finite automata system. There is a DFA machine with us, we have to determine what are the false statements. According to the source of information, there is no MCQ on the paper 1 this time. In the paper 1 all the questions are here from the TOC is a MSQ, and there are 2 numerical answer type questions, and we have a one direct question as I given on the regular expression which are already solved it, and one question on the properties of the regular languages. So that is also covered in the previous discussion. Now let us get into the one more important question which I received from my students. So this is the finite automata system, this is a DFA machine given to us. We have to determine what statements are false corresponding to this diagram. In this diagram, please note the first one whatever you have here, this one is a initial state, one is a initial state. So what is the statement he has given? As for the option A, this is the machine, is it accepting all the strings over the alphabet 0 1 which contains number of zeros in a W is always equivalent to number of ones in a W. I would say here this is equivalent of other alternative way of saying equal number of zeros and equal number of ones. Is it the DFA machine, is it accepting all the strings which contains the equal number of zeros and equal number of ones? That is the statement. Second option, third option I would say B, C and D is asking about there are about 5 states, whether all these 5 states are distinguished states or is there any equivalent states are here. If you look at into the statement number B and statement number C, in statement number 2 he is saying that states 2 and 5 are distinguishable states. That means they are 2 different independent states, they are not equivalent. And C is also saying that 3 and 4 are distinguishable statements, and D is saying that 2 and 4 are distinguishable statements. So we have to determine here which states are here equivalent, which states are distinguishable statements. So what is the idea we have to do for that? This diagram you need to be translate into the table, apply the partition algorithm so that we can get here what are the equivalent states in the machine, what are the other statements are not equal here. So using that mechanism you can easily answer what statements are false, which statements are here true. Now what I do, I just translate this entire diagram into the table and then we identify equivalent states in that. Later on you can identify what options are going to be true, which options are going to be false here. Let us get into the translation of this diagram into the table format. If you do translation of this table, right, diagram to the table, what you would see, there is a state 1 here, let us make it say Q1 as the 1 and Q2, Q3, right, and we have a Q4 and then Q5. There are states of the phi. As you know, in a diagram, this is the initial state as well as the final state, and we have two inputs 0 and 1 here. If you see the transitions of the Q1, you know that this is equivalent of Q2 and Q4. This is the Q4, and similar way if you look at here, this is the Q3 and this is the Q1 here. I am just trying to convert your diagram to the table, and Q3 will get here, it is equivalent of the Q1 and Q2. Then this is equivalent of here, it is a Q1 and it is a Q5, and this is under say Q4, under 1 it is equivalent of Q1. You all just remember, I just renamed it as a Q0 and Q1, Q2, Q3, and it is a Q4 and it is a Q5 here. These are the small changes I have made on this. Once you translate this table into the minimization process, what you will find here, you know, initial states or you know the final states will never be equivalent of any one of the non-final states are here. So in a partition 1 you can find there is a subset of the final states and non-final states. In the non-final states you know that you will get here Q2, Q3, Q4 and then Q5. This is the initial partition. Further partition, if you make whether they are equivalent or not equivalent, what you will get here, Q2 and Q3 if you look at here, this is a non-final state and it is a final state, obviously they cannot be equal, and Q2 if you compare with the Q4 again they cannot be equal, and Q2 and Q5 if you see the Q3 and Q4 both are non-final, under 1 they are equivalent of final states. Ultimately this is equivalent of you know this is going to give you Q2 and Q5 here one set, and you will be getting about Q3 and Q4 you will get into the other set here. In the next step also you will be getting this is equivalent of in P3 also you will be having the same set of elements here if you apply our next step of this partition algorithm. What you will find here, this is again Q2, Q5, then further this is also equivalent of here Q3 and Q4 here. So if you will see the final step, you can understand Q2 and Q5 are equivalent states. Similar manner here Q3 and Q4 also equivalent states are here. So as for the options, what you can do now, let us go into the what statements are false. As for the statement number 1 is asking for the language what this machine is accepting. If you see the statement of the language, all strings containing the equal number of zeros and equal number of ones. That means if there is a string with equal number of zeros and equal number of ones, it is being accepting. If that is the case, I would say W, suppose it is a 0 1. It is the string containing the equal number of zeros and equal number of ones. Is it really accepting? If you see, it is going to be accept here 1 0 and it is this. Similar manner you just take down here 1 0. If you look into this, you will apply here 1 will be coming to this place and 0 will go back to this place, and also apply here few more strings here which contains the equal number of zeros and ones. Definitely you can find here always this machine is going to be terminated at the final states here. So there is a scope for us, this is going to be the true statement, but we wanted to have here false statements according to this one. But you have seen here there is a second state and fifth statement, both are there in the same set, definitely they are going to be the equivalent states. So this statement is the false statement, and definitely 3 and 4 also remain in the same subset, hence they remains as a equivalent states. Definitely this statement also going to be the false statement, and 2 and 4 as you know they are not the equivalent states. Definitely this statement is going to be the true statement, they are going to be the distinguishable statements. So finally what you would say here, the false statements according to the given problem, you will say that B and C going to be the false statements of this problem here. So this is the if this is the exact diagram and if these are the options, definitely these are the probable answers to be this particular question here. So there are totally 4 questions has come on the theory of computation in the set number 1. So all these 4 have been discussed. Thank you. And the next subject will be taken by my friend.
So now we are going to see computer networks related questions which are part of our shift 1 question paper of computer science and engineering. So as part of this shift 1 paper, we have around 6 questions from computer networks. 3 are from 1 mark and 3 are worth of 2 marks. So total 9 marks of weightage is there with respect to this CN subject in the first shift of computer science and engineering GATE paper. As part of that, these are the questions which we have received, and these are memory based only, not exact questions. Okay, so the key may be changed because these are not the exact questions here. Right. So coming to this question statement, a TCP client P successfully established a connection to TCP server Q. Let NP denote the sequence number in the sent SYN from P to Q. Let NQ denotes the acknowledgement sequence number from Q to P in SYN plus ACK packet. Which of the following statements are true? So this is also a MSQ question. This is also an MSQ question here. Okay. So coming to this question, if you recall TCP connection management, we have used a 3-way handshaking concept. So what is a 3-way handshaking concept? Recall. So this is what my client P. This is what my client Q, server Q, okay. This is what my client P and this is what my server Q. So first client P is sending connection establishment request using a packet called sync packet. So this is what my synchronization packet. So for this synchronization packet, what is the sequence number it has mentioned in the question statement? The sequence number is NP, right? NP. The sequence number for this is NP. Then NQ denotes the acknowledgement sequence number from Q to P. So which means that now the Q is giving a piggybacked response here. So what is a piggybacked response? SYN plus ACK. So for this SYN and plus ACK segment, or as for this packet, TCP packet, it is given acknowledgement number but not sequence number, right? It is given acknowledgement sequence number. What is that acknowledgement sequence number? NQ. So this is what my acknowledgement number, that is NQ. Okay, right. So here it is mentioned sequence number which is NP, and here acknowledgement number is given NQ, right. So then what is the which of the following are true here? So if you consider A, option A, NQ is equals to NP, this is wrong. Reason, you know that this is acknowledgement number. What is this acknowledgement number field defines? The acknowledgement number field defines the next expected byte sequence number, right? So this has been received. What is the byte sequence number here? NP. Then NQ is going to be next expected byte sequence number, which is going to be NP plus 1. It must be, NQ must be NP plus 1, but not NP, right? So hence we can say option A is wrong and option B is true here, because this is acknowledgement sequence number. Acknowledgement sequence number is always what? Next expected byte sequence number, okay? Then coming to the option C, the sequence number NP is chosen randomly by P. And option D, the sequence number NP is always starts with 0 for new connection. This is wrong, right? So, but this is correct, right? So the sequence number NP is chosen randomly by P. The sender can choose the sequence number randomly here. So hence, what is the answer for this question? By collectively, B and C is the answer for this question. Okay? Right. Then coming to next question. Yeah, so this is a kind of, this is a kind of typical question, or else you can say analytical question. Which of the following IP header fields are modified by a NAT device? Please mind this, it is mentioned NAT. NAT means what? Network address translation. What address it is translating? It is translating private IP address to public IP address, private IP address to public IP address, okay? Right. So while forwarding from one internal network to an external network. So for example, this is what my organization internal network, this is what my organization internal network, okay? And this is what my external network, this is what my external network. In between these two, I have the router, this is what my router. So generally this router is implementing a table called NAT table. So now I can say this router is NAT device here, right? So NAT is mentioned clearly. So now I can say this is a NAT device. And which of the following IP header fields gets modified? So if you consider here header checksum, obviously it gets modified. Reason, you know that TTL field, time to live field. So time to live field is decremented by a router, right? So this is obviously gets, so since this TTL field value is been changing, automatically header checksum also gets changed. Reason, TTL is part of header. If one field information of header is being changed, then obviously the checksum which is going to be calculated to that particular header is going to get changed. So that's why header checksum gets modified. Then coming to next one, source IP address is mentioned and destination IP address is mentioned. See, since this line is there, since this NAT device, this line is there, okay, since this line is there, source IP address, this is a private IP address. Since it is an internal network, in an internal network you are having private IP. But when it comes to NAT, and when it forwards to the external network, this private IP is being converted to, it is being translated to public IP, right? It is being converted to public IP. So this is not exact question, right? Mind that. So, but as it is mentioned clearly, NAT device, source IP address also possibility is there to get changed. Then coming to C, this is not going to be changed. But coming to the D, it is mentioned the total length. See, is the question is mentioned IP packet header, is it mentioned IP packet header, or else is it mentioned IP fragment header? So this is what you have to check once. If it is IP packet, obviously the total length also not getting changed, but if it is IP fragment, obviously this is going to get changed. So this is also gets changed. So overall, A, B, D are the answers for this question. This is not exact question, one more time I am repeating. This is a memory based question, okay. After releasing the exact paper, might be there is a possibility of changes in the keys, right? But according to this given question, whichever I received, I can say A, B, D is the answer for this question, right. Then coming to this question. So here the file size is 10 power 6 bytes, bandwidth is 10 power 6 bits per second, packet size is 10 power 3 bytes. So by considering these two values, I can calculate number of packets. So number of packets is equals to file size by packet size. What is the file size? 10 power 6 bytes. What is the packet size? 10 power 3 bytes. So bytes cancel, right? How many packets I am having? 1000 packets I am having, 1000 packets, okay. Next, and this is what the network given. So now P is sending 1000 packets to the queue, but in between you are having one R intermediate device is there, which is a packet switch you can say. See, this is the question which is related to your packet switching. And the question is clearly mentioned that there is no propagation delay, we are ignoring it, processing delay, waiting delay, everything is being ignored. So what is the total time that is being taken by the receiver to receive the whole file, which is x into tx plus tp plus x minus 1 into waiting time plus waiting time in the sense which is tq and tproc, okay, and n minus 1 into tx. This is the formula which is the total time that is being taken by the receiver to receive the whole file, right? So this is the packet switching concept, and how the formula is been getting that we clearly defined in our classes. We have given the derivation how we are getting this total time formula. So by according to the question, it is mentioned that this is ignored, this is 0, this is 0. So that what we need to consider, only total time is equals to x into tx plus n minus 1 into tx. What is the tx here? Transmission time L by B. How much amount of packet you are placing at a time? 1000 bytes of packet. 1000 bytes of packet you are placing onto 10 power 6 bits per second channel. So which means that this is in terms of packet, this is L is in terms of bytes. So that's why 8 into 10 power 3 by bandwidth is 10 power 6. So this gets cancelled, tx is 8 milliseconds. So how many hops? X is what here? X is number of hops, right? And n is what? Number of packets. Okay? So then how many number of hops I am having? So this is one hop, this is one hop, right? So total you are having 2 hops. So 2 into 8 millisecond plus n minus 1. What is the n? 1000. What is the n? Number of packets. How many packets you are having? 1000 packets, which means that 999 into 8 millisecond. So if you evaluate this expression, you are going to get 8008 millisecond. But the question is expecting the answer in terms of seconds. So if you convert this into seconds, you are going to get 8.008 seconds. So this is the answer for this question. Okay, right. Then coming to next question. So consider the following IP datagram size of 1420 inclusive 20 bytes of header. One network MTU is 542 and another network is 360. Okay. How many fragments does this receiver can receive here? Okay. So what is the question? It is saying that the question is clearly mentioned that there is a sender. This sender is sending this packet, okay, 1420 bytes of packet it is sending. So through 2 interfaces. So what are this is what my one interface, let's say. Now this is what my router, and this is what another interface or else another network. Through these 2 networks, this is my network 1, this is my network 2. Through these 2 networks, this sender needs to forward the 1420 bytes of IP datagram to the receiver. But what is the network 1 MTU here? The network 1 MTU is 542. What is the MTU of network 2? 360, right? So now this is the sender 1420, which I can write as 1400 plus 20 because it is 20 inclusive 20 bytes of header. So 1400 bytes of data I am having, okay? Now MTU is 542, but by default you know that it is going to be 20 bytes of header and 522 it is going to be. But is the 522 is divisible by 8 or not? Please verify, right? Is it divisible by 8? So it is not divisible by 8, and even 360 also if you consider, 360 means I can write this is 340 plus 20. But 340 is also not divisible by 8. So which is, you should consider here 336 is the data portion, and here 522, whether it is divisible by 8 or not, you can verify. So overall you are going to have 6 fragments. So 6 fragments can be received. 6 fragments can be received by the receiver at the end. Okay. So this is divisible by 8 or not. If it is not divisible by 8, the nearest value you have to consider which can be divisible by 8. Okay. So this is the way how you can handle this question. So answer for this question is 6 fragments. Here you can have 3 fragments. Here you can have 3 fragments, and these 3 fragments get splitted again into two fragments here. So this is being splitted into 2, this is being splitted into again 2, and this is also being splitted into another 2. So overall 1, 2, 3, 4, 5 and 6. 6 fragments you are going to get by the receiver. 6 fragments can be received by the receiver at the end. So this is what another question we have from computer networks. So overall out of 6 questions, we have received these 4 questions. There is one more question is there from IPv4 addressing, but the data is not received. So that's why we are not covered here. So I hope you are clear with the explanations and the respective keys of computer networks. Thank you.
Hello students, welcome back. So here I am come up with some of the compiler design questions which were asked in the today's morning session paper. So here when it comes to the compiler design, is a 1 minute, maybe technical problem, just stay. Hello students, welcome back. Sorry for the technical problem. Here I am going to continue with compiler design questions. From compiler design, there are totally 5 questions were asked. There are 5 questions from the compiler design, and when it comes to the past 5 to 6 years of papers, and this will be definitely the highest number of questions asked. And these 5 questions, in that 5 questions, there are 2 1-mark questions, 2 1-mark questions, and 3 2-mark questions. So 2 1-mark questions 2 marks and 3 2-mark questions 6, altogether 8 marks given from the compiler design subject. And here we have received very less data about the questions, but questions were asked, one from the parser chapter, and in the parser chapter the first question that what we collected is, which of the following is a bottom up parser? which of the following is a bottom-up parsers? There are set of options are given. That option A given LL of 1 parser, option B given shift reduce parser, and option C given predictive parser, and option D given LR parsers. As you know that the parsers are classified into two types, top-down parsers and bottom-up parsers. And LL of 1 is a top-down parser. Question is about bottom-up parser, so it is incorrect. Shift-reduce parser is a bottom-up parser. And predictive parser is a top-down parser, so option C is wrong. And option D, LR parser is a bottom-up parser. And because the question is MSQ, multiple selection question, and both the options are correct. That is, shift reduce parser and LR parsers are the bottom-up parsers. And here one more question that was asked is, on the grammar it is given, and the grammar, whatever the grammar that given, and it is given the grammar is S tends to DAT, and it is given a placeholder 1, and T tends to AS and BAT, and one more placeholder is given and it is mentioned with a number 2, and one more grammar rule, it is given R tends to placeholder 3, R epsilon is mentioned, and this is a grammar given, and also given the first of S equal to DCF and first of T is AB epsilon, and also given the follow of S equals to follow of T equals $C and F is given. And the question that it asked is, what are these placeholders? Means what should be the productions in the numbered places 1, 2, 3, what should be the productions? And set of options are given. In that options, it is mentioned what could be the production in the place of 1, 2 and 3, it is mentioned. So for the options, we have to see for which options this first of S and T and follow of S and T are correct. And here I got a data that one of the option, it is mentioned S tends to RF, and this is a first one, first placeholder, and the second placeholder is a T tends to epsilon, and the third placeholder is R tends to CATR. This is a third placeholder. Like this, options are given A, B, C, D, and here I can say option A is the correct one. How option A is the correct one? How to solve this question? Just simply you place these options and check with an options. That is a simple way of answering the question. S tends to RF, and second one is T tends to epsilon, right? This is a T tends to epsilon, and the third one R tends to, in this place of this, we can say R tends to CATR, right? CATR. So let me write in a neater way. So just I am removing this, I am going to write with a white color so that you can understand easily. Look at what should be the first placeholder, S tends to RF, and the second placeholder, this is T tends to epsilon, and third placeholder CATR, small c, small a, capital T, capital R, right? Now the question is, we have to check, like by applying these placeholders from the options, we check this first of S and first of T are correct or not. Now what is first of S? DCF. D correct, because first of S is D, and first of R, what is first of R? C correct, right? And first of R is epsilon. When R is going to become epsilon, then S is going to start with F. This is correct. And first of T, A clear, B clear and epsilon clear. This is straightforward. So because epsilon is given, the second placeholder requires to have an epsilon. And it is also given fall of S and fall of T is $CF. Look, fall of S is a starting non-terminal and fall of starting non-terminal is dollar, that is correct. And fall of S is fall of T, you look at here what S is following, T. So fall of T you look at, fall of T is fall of S, means both fall of S and fall of T are same, and here fall of T is fall of T, same. Look at here in this production, fall of T. What is fall of T? First of R. Fall of T is first of R. Now what is first of R? Here you can see symbol C, so C possible. And first fall of T is first of R is C possible and epsilon possible. When this R is becoming epsilon, then fall of T is going to become fall of R. Now when it comes to the fall of R, here you can see what R is following. R is following F, so that F is also possible. It means in these three places, if we have these production rules, the given first of S, first of T and given fall of S and fall of T are correct one. So answer for this question will be this option. That option is mentioning the placeholders S tends to RF, T tends to epsilon and R tends to CATR. This is one of the question. And there are three more questions. We don't have a proper data. And one question is given, the precedence and associativity of the operators are given. And one expression is given and asked to evaluate the expression, and this could be a numerical answer type question. How you have to evaluate it? The evaluation should be according to the precedence first. If more than one operator have the same precedence, those to be evaluated according to the association. It is simple expression evaluation. You will get some answer that as a numerical answer type question that you have to fill in the blank. This is another third question. And the fourth question, they have given a syntax directed definition is given, SDD is given, and they have given some string. They have given some string and asked to evaluate the parse tree for this input string and asked to find the value of S. The value of S they asked to find. So it is a simple procedure. We have done many questions in our classroom that using the grammar we have to construct a parse tree for this input string and evaluate the parse tree according to the syntax directed definition, means the translation rules that are mentioned, and we have to calculate the value of this. That is the fourth question. And the fifth question, it is for 2 marks it is asked, and it is also for 2 marks it is asked, and the fifth question is on control flow graph. The fifth question is on control flow graph. They have given set of 3 address code statements, and asked to find the number of basic blocks. How many basic blocks in the 3 address code statements? This is a one, and we don't have a proper data of that set of 3 address code statements, but we came to know that there are 7 basic blocks in the code. 7 basic blocks. And it is also asked the number of statements in the largest block. Number of statements in the largest basic block. In the largest basic block. The number of statements in the largest basic blocks are 6. And if you could have answered this question as 7 and 6, that is a perfect answer. Right, and these are the 5 questions that were asked from the compiler design subject, and these 5 questions comprises 8 marks. This is a very good weightage given in the GATE 2024. That's all about our live session. about the memory-based questions. Hope you have enjoyed our session. Wishing you all the best, hoping for the good results. All the best. Thank you.